What if our final resting place wasn't the Earth, but the silent void of space? Forget the myths. Science reveals what truly happens to a body in a vacuum. When we hear vacuum, most of us picture a completely empty, airless abyss of cold and silence. That's pretty close, but with some important scientific nuances. A vacuum isn't just the absence of air. It's a state where gas pressure is far below atmospheric pressure. The fewer gas molecules in a given space, the closer we get to a perfect vacuum. On Earth, we can only create partial vacuums in labs by pumping air out of sealed chambers. But true, near-perfect vacuums exist in space. The particle density there is so low, pressure is almost non-existent. Unlike Earth's atmosphere, which constantly presses on us with about 101 kilopascals, space vacuum pressure approaches zero. This lack of pressure, or decompression, is key to what happens to a body in that environment. No air means no oxygen, obviously. But more importantly, the absence of external pressure affects internal processes used to constant atmospheric pressure. And let's not forget extreme temperatures, though that's another story. Bottom line, a vacuum isn't just nothing. It's an aggressive environment with very specific properties. Ones Earth organisms aren't built for. Understanding these basics helps us understand what follows. What happens to a body when pressure vanishes instantly? Are you ready to see how the absence of atmosphere makes blood boil and gases expand? So, a vacuum is an extremely low-pressure environment. What happens to the human body first? Forget Hollywood myths of instant explosions. Reality is more complex and specific. First, decompression. Inside us, blood and tissues contain dissolved gases under atmospheric pressure. When external pressure disappears, these gases expand rapidly. Lungs, intestines, sinuses, all air-filled cavities are affected. The body swells like a balloon, increasing in size. It won't rupture, but it will be significantly deformed. Simultaneously, liquids start to boil. With no external pressure, water's boiling point drops drastically. In a vacuum, blood and other bodily fluids can boil at body temperature, 98.6 degrees Fahrenheit, 37 degrees Celsius. This is ebulism. Water in tissues turns to vapor, causing further expansion and cell damage. In seconds, the skin blisters and gas pockets form underneath. Blood, still in vessels, begins to boil, creating bubbles that stop circulation. All this happens almost instantly, within 10 to 15 seconds, before oxygen deprivation leads to unconsciousness and death. It's a rapid, destructive process that permanently alters the body's structure. Nobody tells you how a body in a vacuum stops decaying, transforming into something else through sublimation and cosmic radiation. This will change how you think about what happens after death. The dramatic first moments are over. The body has swelled, fluids have boiled, consciousness is gone. What happens next, long term? The vacuum reveals its unique properties as both a preserver and a destroyer. The main difference from Earth is the total absence of oxygen, meaning no bacterial decomposition. On Earth, microorganisms start the decay process. In a vacuum, this simply doesn't happen. No air, no liquid water, therefore no environment for bacteria. The body won't rot as we know it. Instead, sublimation begins. Any remaining moisture that didn't evaporate immediately transitions directly from solid, if it's cold, or bound state in tissues to gas, skipping the liquid phase. This completely dries and dehydrates tissues. The body slowly mummifies, losing mass and volume, becoming a dry, brittle shell. But that's not all. In space, there's no protective atmosphere, so the body is constantly bombarded by cosmic radiation. High-energy particles. This radiation slowly breaks down molecular bonds in tissues, damaging DNA and altering chemical composition. It might not be visible externally, but on a microscopic level, tissues degrade. Temperature also matters. The vacuum is extremely cold in the shade, causing freezing, and extremely hot in sunlight. Either way, it's a unique preservation scenario unlike anything on Earth. Imagine future archaeologists exploring a distant planet, discovering something incredible, a perfectly preserved body. This isn't magic, but the result of vacuum conditions that transform decay into extraordinary cosmic mummification. We know the vacuum deprives the body of fluids through sublimation and prevents decay. But what does this mean for its final state? In space, the body undergoes a very unusual, natural mummification. No Egyptian balms, just pure physics. When all moisture evaporates, tissues become extremely dehydrated. Skin, muscles, internal organs, everything dries out, becoming brittle and rigid. The body doesn't decompose, but rather dries out to a parchment-like state. The absence of oxygen, which usually oxidizes and breaks down organic matter, helps preserve the structure at a molecular level as much as possible. Extreme space temperatures also play a role. In the shade, where temperatures plummet to near absolute zero, the body freezes solid, slowing any chemical reactions or decay. In direct sunlight, where temperatures reach hundreds of degrees, it will be heavily irradiated and dried out, but won't burn due to the lack of oxygen. The result is not a rotting corpse, but a dry, brittle, possibly deformed cosmic mummy. Its appearance depends on its initial position, radiation exposure, and orientation to the sun. It's a unique artifact, a testament to the power of cosmic conditions, which could persist for thousands or even millions of years, unless mechanically destroyed or damaged by radiation. A striking example of how emptiness paradoxically becomes a preserver. On Earth, a human body decomposes in decades, returning to the soil. But in the vacuum of space, with no bacteria or moisture, it can last for millions of years. Is this science fiction, or a radical alternative to traditional burials that occupy 10 square meters of land for centuries? We've explored what happens to a body in space. Now let's compare it to Earth burials. On Earth, whether buried or cremated, the main principle is returning organic matter to the natural cycle. In traditional burial, the body decomposes under the action of soil bacteria, insects, and moisture. This takes years, sometimes decades, until soft tissues disappear, leaving only the skeleton. It's part of the ecosystem, nourishing the soil and participating in the cycle of matter. In a vacuum, the picture is radically different. The absence of oxygen, bacteria, and liquid water completely eliminates decay. Instead, sublimation and dehydration occur, turning the body into a dry, brittle mummy. This cosmic mummy can persist for thousands, even millions of years, if not destroyed mechanically or by high-energy radiation. This is radically different from Earth, where even mummified bodies in dry conditions still undergo slow degradation. Could space burials be an alternative? Technically, yes. Some companies already offer sending capsules with ashes into space, but it's mostly symbolic. Fully burying a whole body in a vacuum faces huge ethical, legal, and technological challenges. The cost would be astronomical. There's also the question of space pollution and the need to regulate such practices. However, scientifically, a vacuum offers a unique means of preservation, not eternal life, but astonishingly long existence in an unchanged state. It forces us to rethink life and death beyond our planet. Our journey into the cosmic vacuum has shown that even after life, the universe holds amazing and sometimes frightening secrets. If you're as fascinated by the unknown as we are and ready to dive into the deepest mysteries of existence, subscribe to Mysteries of the Spirit and like this video to stay updated for more discoveries.